right, staying on topic here. We're back for more Glue. So you wanna introduce yourself first to the people
Yep,
watching, please?
absolutely. So my name is Kinshuk Fahre. I'm a principal product manager responsible for platform, the Glue platform. So what Aniket was describing was the awesome fancy stuff, the application. I actually run the Spark and the engines. So
Well, the engine is just
So
as
kind of like a
important.
front end, back end kind of scenario we're talking about here. Yeah.
yeah, I think we can simplify
Lambda,
it to that.
Power.
Yes,
Yeah.
yes.
Okay.
But we're here talking specifically about Glue for Ray. So I want to know first off why you built a feature or service just for one person, and who is Ray?
Yeah.
That's a good one.
Bad joke.
So
Bad joke.
I knew you were
no,
going to go there.
it wasn't as bad. So I think it's interesting that uh, the context that we are operating, right? So we are a data integration service, as Aniket mentioned. We basically help users across the personas. So not just the developers who are comfortable writing, distributed programming, they are comfortable writing, Spark code or Python code. But we also, support the visual users who are comfortable, with the visual interface that Aniket just showed on the Glue Studio. So the idea here is to make sure, like, our mission is that we want to make it easy for users across the skill set to ingest data from across a variety of sources using a variety of tools and technology. So that's the vision that we have set with Glue. Now, with that vision, one of the interesting thing that we offer is we offer a variety of data processing engines. So Spark, as you probably know, is the most popular distributed processing engine. And we also offered a single-threaded Python engine. Now, the reason I'm qualifying it as a single-threaded Python engine or single-node Python engine is because Python in general, right? Python is very easy. Everyone's kid at 11, 10, 12-year-old is learning Python. The beauty of Python is that, you don't have to do a lot of memory management. And as you can see, I have done a lot of C programming, and malloc which is used for memory allocation, is the dreaded construct, which makes it difficult to actually for a new programmer, or at least for an 11-year-old to write C programs. And that's the beauty of Python. Like, everyone loves Python because it's very, very easy to get started and to be actually good at it. The single node Python engine that I was talking about, right? Actually, a lot of customers use it just for, like, hey, I just want to ingest 5 gig of data from this S3 location, right? I don't want to, work on Spark, or I don't need to work on Spark. I can just code it in Python.
Yes. My favorite, I was going to say, when you were saying C, because some of my favorite C programming today is just using Python to call C libraries.
Yeah, that's a good one.
Yeah.
So, and I think that construct, right, made it the popular language. Now, the challenge is that to achieve that, there is something called global interpreter lock. And for someone who wants to just Google it, and you will find exceptionally opinionated individuals just talking about the value. Exactly.
Multi-threading in Python is not necessarily very simple, and it's also very opinionated too.
It's
about
very,
how
very
people
opinionated.
do it. Yeah.
And there are, so that global interpretation lock, ensures that it's only one thread which is operating at a given moment, which makes it very, very difficult to distribute Python across multiple nodes. Now, why would you want to distribute Python, right? If you're processing, 100 gigs of data, unless you have a machine which has, 120 gig of memory, your options are, let me split the data into chunks and process the chunks, right? If you're trying to process this on a single node machine with reasonable memory, 16 gig of memory, you have to process it in chunks. Or you basically have to say, you know what, I am going to manually distribute, and I'm not going to recommend this. I'm going to manually distribute my Python code and my data so that I can run this in parallel. Both of these options, like option one, is going to slow down your processing, because now you are going to do one process, second process, third process, and then at the same time you have to keep track of what data you already processed. And then suppose fourth job failed, so you are trying to figure out, which row number got ingested and processed, and then I have to rerun only that job, right? The second option is very, very difficult to achieve. It increases the complexity of the code and complexity of the ingestion pipeline. Like parallelizing this without having a framework makes it very, very difficult. So to solve this problem, and this is where, who's Ray? So
Enter Ray.
exactly, enter Ray. What we actually have done is we are using Ray.io, which is a unified compute framework, which allows you to actually distribute Python across multiple nodes.
Okay.
And, you can visit Ray.io to learn more about this. It's a very new, relatively new framework. It's developed, by some of these Rise Lab in Berkeley, and you can actually visit that. But one of the key advantage is that when you run it on Glue serverless, which means you don't have to worry about managing infrastructure. So all you have to do is, again, similar to what Aniket described, you just focus on data and the transforms, the actions that you want to take. AWS Glue takes care of infrastructure management for you. One key call out, and I think this is one of the questions that we get asked, is like, hey, what about cost? Because when you're processing data, cost becomes a concern. We actually have a built-in automatic scaling, and what that does is it right-size your compute. So what we do is, if you have need for 100 nodes, we'll spin up 100 nodes. But what we have seen is that during the course of data integration, you don't need 100 nodes all the time. Like during the phase of ingestion, you probably need 5. Maybe during the transforms, you need 25. And maybe during the writing, you probably need another 10, right? So your actual data processing looks like a step function going up and then going down and then going up. With Ray, what we have done is we have actually developed the ability to scale and right-size your compute in a very, very fast manner. So you are only paying for the compute used only during the duration of the job. And since we are right-sizing the compute at the time all the time, you don't have to think about even right-sizing your data processing, because Glue is doing that for you.
So is this like, I'm just trying to work out if I can say this. Is this like auto scaling for ETL?
Absolutely. And this is auto scaling at a very, very fast level, right? So what we have done is at auto scaling, we scale, and in fact, you can see this on the graph when you execute the job. I recommend checking out the reInvent video, which showed these things. You actually, when we add 10 nodes, those 10 nodes are added in under 1 second. So in sub-second time, we can actually scale up 10 nodes. So at the moment your driver says, hey, I need 10 nodes to process this data or these tasks, we immediately scale it up to 10 nodes, and that's it. Like, and if you say, what, driver says, hey, I'm done with processing this data and I see idle nodes, under 1 second, those nodes automatically shuts down.
I was checking out Ray, Glue for Ray specifically before this, and one of the things that was really cool to me was, especially for Python devs, right? Common libraries that you'd be using in data processing are there, right? They're already there. You got pandas, you've got our AWS Wrangler.
Correct.
And it's very easy to include. I was looking too. How do you include other libraries too? Do you want to talk about that a little bit?
Yeah,
why Python
absolutely.
devs will love this?
So we obviously have built-in libraries, right? So you mentioned pandas, which is one of the most popular libraries that's already available. And what we have noticed is that customers actually have built in their own libraries that they have done over years for custom ingestion, custom transforms, variety of use cases. And customers can provide those libraries as they start their job, or actually they start their interactive development environment.
Right. Totally. Well, Kachuk, I know you've got to leave us soon. Do you want to tell people that are watching, some of the recommendations you have for getting started with Glue for Ray? Any good places to go to learn
Correct.
more?
So Glue for Ray is in preview in 5 regions in AWS. And I recommend actually going and checking out the demo that we did at reInvent.
Nice.
And there are a couple of blog posts which talk about the common design patterns around Ray. So do check those out.
So the video for that should be, if anyone's watching and wants to check it out, it should be on our YouTube AWS Events channel. If we don't have it, actually, we have a link for it here. Here we go. I'm going to throw it up on screen right now. There we go. If anyone's interested in going checking that out.
Love it. Well, Kachuk, thank you so much for joining us. I know you got to run to your next thing, but we really appreciate you being here and telling us more about Ray. I now feel like I know who he is.
Awesome. Thank you, folks.
All right. We'll see you next time.